Okay, well, I'm going to do an experiment today, and it has to do with which types of water will prevent oxidation inside cells. And I'm actually started this experiment a couple of days ago. I had an apple I just wanted a slice of an apple. I didn't want a whole apple. And I happened to have this jar of ionized water sitting there that I was storing basically on another experiment I was doing, and it had about a 10 pH and a negative 250 ORP at the time. It had been storing for about a month in this mason jar, and these mason jars are the only way that I've found to store ionized water for long periods of time. Now, that's another story and another experiment. But I meant to just eat the apple the next day, but I didn't get to it. So now here it is 2 days later, and it's still not oxidized. I mean, it is a tiny, tiny bit oxidized along the edge, but for the most part, it's a great looking apple, and I'll eat that later. But, and I actually, I'm wondering what the pH and ORP of the water in there is after the apples have been sitting in there. That's curious too. I'll test that later. But now this experiment I'm going to cut an apple. I'm going to pour some fresh ionized water. I'm just going to use my drinking level 3 of the Athena water here. And I'm going to have ionized water in one, and tap water in another, and acidic water in another, and I'll see, we'll see what we see in a day or 2 or 3 or something, whenever I get around to it. So first thing, I guess what I'll do is I'll go ahead and fill these jars. So this I'm going to put ionized water. Let me get my ionizer going here. And acidic, wait a minute, I've got an A on this one. I've got ionized written on this one, and then acidic water on this one, and then the other one that doesn't have anything written on the lid will be tap. Alright, so I'm going to start the acidic water going in this one. I have to literally fill these to the point where they're overflowing, because that way we eliminate the air bubble, and air is very highly oxidizing, and what we're looking for is just the antioxidant properties of this ionized water, and without being mixed with air. Alright, well, we're getting there. And these have to overflow, like I said, so we might make a little mess here. And I'm going to let it dome up a little bit, and oops. Okay, now make sure I put the right lid on. Now that is domed up, and when I put the lid on, it will spill over because it's so full. Oops! I forgot to put the apple in there. Hold on 1 second. Alright, so this is the ionized water. I'm going to cut this apple. Okay, so I've got one piece that's going to go in this. I'm going to put it gently in here because I want it to have no air bubble. One piece that's going to go in this mason jar, and I'll have to it wants to float, so I'll have to push that down on it. Oops, wait a minute, I've got the wrong, that's the acidic lid. Hold on, let me get the right labeled lid here. Okay, I think I need to just pour a little bit more ionized water in there, because we've Actually, what I'll do is I'll put enough in these cups to test the acidic and the ionized water now. This is ionized water and this is acidic water. Alright, so I'm going to overflow it. Okay. And then screw the lid on. I just want to check now that I've got the lid screwed on. I want to see if I have an air bubble in there. No. Yay, no air bubble. Alright, so that's the ionized water with apple in it. Now here's the acidic water. Whoa, alright. No air bubble. Good. The point with no air bubble, I think I made it already, but just you just don't want any air in it because the air just makes it oxidize very quickly. Alright, and now I'm just going to do this one with tap water. And I have made a mess here. Alright, get another piece of apple here. Alright, there we go. Ah! Somebody once asked me if the lids that were all one solid piece were might be better than these two-piece lids, and absolutely no. The answer is no, because you would not be able to have no air bubble in there. The big solid lid would keep air in there as you're screwing it in, and you could not achieve this with no air bubble. Alright, so now we've got our 3 jars. Alright, and a mess. Alright, so now what I'm going to do is I'm going to test this water that is the ionized water. Let it sit in there for a bit. Seems like my ORP meter appears to be a little off. It's this is, you know, every day or two, let's say 2 days, my ORP meter needs cleaning, and see it's definitely needing cleaning because it's only showing up as a negative 323 and a 10.1 pH. So I know that is incorrect, because I know the Athena gives more ORP than that. So what I'm going to do is I'm just going to show you the process I do, and I've got a whole blog post about this if you want to read about it. But this is the process I do to clean the ORP meter. Alright, so first step, I didn't realize I was going to have to clean this ORP meter today, so I'm not really ready. I have to get my little sandpaper out. I've got this 220 point sandpaper, which is very fine, and this is what I use to clean the little head or point probe of the ORP meter. So First thing though is I'll dry this. Just dry the probe. Just kind of get a paper towel in there. There's slots, so you can kind of get something in the slots and brush it by the probe and dry it. Alright, so then the next thing I'm going to do is use this sandpaper. Very lightly, I'm going to, there's a little needle probe in there, I'm going to lightly sand the calcium off of that. And if I do it too hard, there's platinum coating these probes. And if you do it too hard, that platinum, of course, you don't want that to be sanded off. So you just want to do it very lightly. This is not what the manufacturer suggests, by the way. But I've had this ORP meter now for, I'm going to say, 3 years, maybe longer, and it is still going great. It gives me good readings, and the only way it would give me good readings is if that platinum were still intact on the probe. So this light sanding isn't hurting it. The solutions that are, number one, expensive, and number two, very time consuming, really don't work very well with this negative ORP water. They're meant more for like the just tap water, or the water, they're meant more to be used with a fish tank with normal water, not ionized. And they just get all scaled up, and then they don't read properly. Well, I think that should do it. I'm just going to check and see if that does do it. So here's the ORP meter. Oh yeah, that's much better. See, this is, more the range. When I test the Athena so often, it cleans itself on a continuous basis, so it itself does not need this little sanding process that we just did here. Now, many other water ionizers their plates do get dirty, just like the probe of this ORP meter did. But that wouldn't happen with the Athena because it's got a continuous cleaning. That's just an automatic part of its. It's not every so many liters it cleans. No, it's continuous all the time. So anyway, that's like a 751 ORP. And then let's take a look and see what the pH here is of the. Oops, wait a minute, that's my testing solution. Let me put the pH probe in the ionized water and see. Hold on, sometimes you have to kind of wiggle it to let it settle down a little faster. It's probably going to be up around 10, and that's just typically level 3, and the Athena, that's what I usually drink at, level 10, and about a negative 750 ORP, and which is just fantastic, by the way. Alright, so it's still going up slowly now. I could say it's a 9.8, which is close to 10, it's something close to 10. Alright, okay, so that's the Athena ionized water. Now, let's take a look and see just the pH of this acidic water. This is what was coming out of the acid water hose while I was pouring the ionized water. Oops, that's ORP. Hold on. I just want the pH. The ORP of the acidic water I don't typically test because it is it's very hard on my ORP meter. So I avoid, once you have your ORP meter, any people who are wanting to get ORP meters, there's a lot more to these than it looks easy, but it is not. Alright, so this is just only lightly acidic, 6.7. Hold on, that just seems too weird. Hold on. Let me... Yeah, I guess that's correct. And it's like a very light acidic. Well, you know, I mean, it's not the strong ionization, basically. So it's like a very light acidic. And say a 5.3 acidity. All right. So that is what is in my acidic water containers. It's not that acidic. It's really close to neutral. Closer, it is somewhat acidic. All right, the next thing I'm going to just show you is the tap water, because St. Louis tap water itself comes in quite high, and I just don't always show people that. I show people that every 10th video. So I'll just show it to you. This is the 10th video. Here you go. Now this is St. Louis tap water. And you know, this unfortunately, this is not an instantaneous process. It has to do this little settling down thing. But it's going to be somewhere around 9.5-ish. I mean, I suppose there is some room for a little bit of, yeah, it's about a 9.1 or 9.2. It's pretty much settled down. So that's a pretty high pH coming in from your municipality, but that's what St. Louis does. All right, so I guess next time we'll, there was one more thing I was going to do. I was going to show you this. Now, let me just get this place cleaned up a tad before I do that, because this is just like too messy for me. Okay. It's like, oops. Dang. Gotta do this faster. There we go. All right, so now I'm going to just do a couple of things. I'm going to test this water, and like I said earlier, I stuck it in there at about negative 250 and a ORP, and it was about a 10 pH. So I'm going to actually I just need 1 cup here. Pour some water in here and then test it. See what both the ORP and the pH come out to be. You know, that is pretty amazing. The ORP actually went higher with the apple in there. Is that not crazy? Look at that. It was a negative 250 ORP, and this water had been sitting there for like a month, and now I've sat the apple in there, and holy Toledo, I just cannot believe that the ORP went up like that. I think I made a discovery here. Apples, no wonder they say an apple a day keeps the doctor away. Holy smokes, that's very antioxidizing, just the apple itself. Now the pH, that needs to settle down. Let me just wiggle a little bit. No, man. The pH, this is like, whoa. The pH went down to a 5? That can't be. I'm going to have to repeat this experiment. So the pH went down, ORP went I have never seen anything like this before in my life. Holy Toledo. The pH went down to 5. ORP went down to a negative 466. This is actually quite significant. The only time I've ever seen anything like this before was one time when I added a couple of drops of lemon juice to ionized water, and it made the pH go down, and the ORP pretty much stayed the same. And I thought that was pretty amazing. I was doing that experiment to simulate what the tiny little droplet of stomach acid would do as your water. If you drank ionized water when you weren't eating, and it went right, directly straight into your intestines, and water doesn't have any calories, so it doesn't undergo digestion, or it doesn't stimulate any more stomach acid. And I was just simulating what that would be, and it was just tremendously wonderful. But anyway, this is just amazing. 5.0 and a negative 469. Holy Toledo. Now, let me just try this apple. Actually, I have to pour this water out to even get these things out. They're so squished in there. Okay. I just want to see what happens to the apple. I'll pull this plate up here again. This is the apple that I just cut. Here's the apple slice that I put in there. It actually, seems softer than a crunchy new apple. So some change has occurred in this apple. I'm going to say it still seems solid, but maybe just a tiny bit soft around it. But let me taste a bite. It's still crunchy, still tastes like apple, but I'm going to say it has a little bit milder taste, as if it were cooked a little tiny bit. You know how the apple tastes in an apple pie? That kind of, it just has a slightly altered taste from the brand new fresh. But it's good, so I will definitely eat it. Okay, well, that's the experiment for today, and I will get back with you about the results of the comparing these three over here. The acidic water, the tap water, and actually this is the acidic water, tap water, and the ionized water for storing the apples. There you go.